My science fair project is called Colorful Electrolysis. And electrolysis is the chemical decomposition produced by passing electric current through a solution or a liquid. And one of the items I used to do my science fair project was 2 pencils. And these 2 pencils are called electrodes. And one electrode is called the anode and the other electrode is called the cathode. The pencil that's connected to the positive side of the battery is called the anode, and the pencil that's connected to the negative side of the battery is called the cathode. My hypothesis for my experiment was if the quantity of current is varied, the time taken to decolorize the brine solution varies as well, which means if the amount of current produced by indulging voltons is increased or decreased, the time taken to decolorize the brine solution or make the brine solution colorless varies as well. Okay, so the materials to do the electrolysis of sodium chloride include a measuring cup, salt, water, food coloring, batteries, alligator clips, a cup or a beaker, a stirrer, a spoon, and a napkin. To prepare the solution for the electrolysis of sodium chloride, first you pour 50 ml of water. And then you take a teaspoon of salt, and then you stir so it's a saturated solution. Saturated solution means it's well mixed in with the water. And then you take about a pinch of food dye, and then you stir. And then you pour your brine solution into your beaker cup. To begin my experiment, I first take the solution which I prepared earlier and 2 pencils. I've scraped the ends of both pencils to the leads on both sides, and I've taped the pencils in the middle. I've also taken a 9-volt battery, and I'm going to connect them to the pencils. Using alligator clips. And now I dip the pencils into the brine solution. The reason I used pencils for my experiment was because pencils contain graphite, and graphite is found abundantly in nature, which means there's a lot of it. And graphite has a high melting point, which means that I only connected about like 9 volts, but even if you connect about 81 volts or more than that, the graphite won't melt and it would still make the circuit complete and still pass the electrons. Pencils are called electrodes in this experiment. The pencil that's connected to the positive side of the battery is called the anode, and the pencil that's connected to the negative side of the battery is called the cathode. As you can see, there's little gas bubbles evolving from the tip of the electrodes or the 2 pencils, and this is due to the gases evolving, such as chlorine and hydrogen. And if you come really close, you can smell chlorine, which is proves that the gases are evolving. This is the decolorized brine solution. As you can see, it turned colorless. And when compared to this solution that we made earlier, we can see that this is colorless and this is still orange. So there's a drastic difference between those two. And the reason this brine solution got decolorized was due to chlorine. During 45 volts, it took about 3 minutes to decolorize the brine solution. But when I used 9 volts, it took about 9 minutes, where there's a drastic difference between those two. And this proved my hypothesis correct. The time taken to decolorize my brine solution did decrease when I used a higher amount of voltage, and this proved my hypothesis correct. And due to the separation of chlorine, the solution left a foul odor that I could smell. And I found out that if you use the same two pencils or the same two electrodes, the process of decolorization would go much faster when compared to using a new pair of anode and cathode. So for precise and correct results, always use a new pair of anode and cathode. So what really happened in this experiment was all the positive ions, such as sodium and hydrogen, went to the cathode because positive goes to negative, and all the negative ions went to the anode because the anode was positive. The positive ions include sodium and hydrogen, and the negative ions include oxygen and chlorine. When the hydrogen came to the anode, it picked up a free electron, and normally when ions pick up electrons, it's to make its shell stable, and this is what happened. Hydrogen came to the gas bubbles.